So hi everybody, my name is Christian Decker. I'm a software engineer and researcher at Blockstream. And I'm also known as the first ever Bitcoin PhD because that's what I did before this. So just a show of hands, how many of you have heard about Lightning? Okay, quite a few hands, probably because you read it off my slides. How many of you know how it works? How many of you know what it's good for? Okay. I have people that know how it works but don't know what it's good for. That's a weird mix. Okay, so my presentation is basically going to be where did we come from, why are we using Lightning, what happened during the last year, because I gave this presentation last year, and we had just started, and how the network evolved, and how it is looking today. So first of all, what is Lightning? The Lightning network was introduced by a paper back in 2015 by Joseph Poon and Tej Dryja. And the shortest description I could find is basically a decentralized system whereby transactions are sent over a network of micropayment channels, aka payment channels or transaction channels, whose transfer of value occurs off blockchain. So the key words here are off blockchain. Basically, what we do is we create a relationship between two endpoints. We take some funds onto the Bitcoin blockchain, lock them in, and now start trading between ourselves. And only once we finished our trading back and forth, we will go back to the blockchain and settle on the blockchain. The network part comes from this multi-hop relationship that we can create on top of Lightning. Namely, I can promise you some money if you forward it to somebody else, and we can basically reach any point in the network through multiple hops in this payment path. Okay, but the next question would be, why do we actually want this? And this is where the holy trinity of Lightning comes in, of scalability, privacy, and permissionless innovation. So scalability is probably the one that you've already heard about the most, right? Scalability is a major limiting factor of blockchain technologies in general. If you know about Bitcoin, you will know that Bitcoin transactions are limited to 3 to 7 transactions per second, nowhere near the levels we need for truly global adoption and this real-time payments that we'd like to do, and IoT use cases, and even competing with Visa is hardly doable. So with Lightning, each channel can perform up to 500 transactions a second. So if we enter in an agreement, we can update our agreement 500 times per second. And this is even on a non-optimized version of C Lightning, just between two endpoints. So how do we increase the capacity of the Lightning network? Well, we open new channels. The other advantage of the Lightning network is that it allows you to do true real-time payments. Because we are basically trading back and forth who owns what part of the money that we locked in. Basically, at the time we updated our agreement between ourselves, this transfer is final, right? I can put $10 on a table and I can push them over to you, and the second you receive those $10, they're yours. You don't have to wait for the Fed to actually settle this payment. Privacy is an advantage that many people don't hear about too much, but it's very important, right? When you do a Bitcoin transaction on the Bitcoin blockchain, you will leave a trace that will be forever in that blockchain. You will leave. Every coffee you buy is leaving traces that are then mineable and can be used to create profiles about you. What we do in Lightning is basically we move those transactions off-chain, not leaving a trace on-chain, and what we settle on the blockchain is basically just an aggregate of the agreement that we had between ourselves. And the third point is that we have this very fast experimentation that is allowed, that is given to us by this protocol just being run between the two of us, right? We can agree on running a new protocol. We don't have to change the whole blockchain in order for us to have a new change. And this allows us to basically very quickly iterate through designs of off-chain contracts and move very quickly in designing this. Okay. So where do we come from? Last year, we started with the first few deployments. Like I said, in 2015, the paper came out. In 2016, we started developing this. It took us about 2 years. And in early 2018, we finally got started deploying this. So short timeline. In 2018, we started with the first few shops, namely Bitrefill, TorGuard, and the Blockstream store accepting Bitcoin on the Lightning mainnet. And we were heavy users of the hashtag reckless, because this is new software and you shouldn't put your life savings in it. But it was also good to get started experimenting and sort of starting people adopting Lightning and people starting to experiment with this. This was pretty well received. So the next step was we released clients for the mainnet. Up to that point, we basically were looking for developers that were taking our source code, compiling it, and running it on their own. And now we started to make it incrementally easier for people to actually get started using this. So the 3 main implementations, LND, Eclair, and C Lightning, published mainnet releases, and we sort of tried to get people to adopt it. And the next thing that happened is that people started organizing around these things. Fulmo started his hack days in Europe. There were meetups in the US, and people got really excited about Lightning. Some people more than others. We were actually denial of service attacked. The good news here is that the denial of service attack basically proved that the network as such is resilient against these attacks, and it didn't have a huge impact on us. And finally, for the more developer minded people, we had our second Lightning specification meeting in Adelaide, Australia, where we basically took what the entire backlog of ideas that we wanted to have, that we came up with during the development of Lightning, which was deemed sort of extra to the version 1.0 spec, because we wanted to ship that as quickly as possible. And that was put back on the table, and we decided which features we'd like to have in the next version of the specification. More on this later. So 2019 so far, we've implemented a couple of features. More features are to come. Definitely an interesting time to get started on the Lightning specification. There's so much to do and so much exciting features that we'd like to implement. And on the community side, there was the Lightning Torch event, something that none of the developers initiated, but some members in the community thought, hey, it would be cool if we just were to send around the payment over the network. And so everybody just increments the value a bit, and then whatever happens to be in the final payment, we'll just send to Venezuela as a charity. So this took off in a big way. I actually had a video of this, but for technical reasons, I can't show it. But just look on YouTube, LN Torch. It's an amazing video. Jack Dorsey participated. We had people sending Lightning payments from airplanes, from space. It wrapped around the world multiple times, and it's just an amazing social experiment to see where people will send stuff. And we are getting started on integrations. So I personally am on the W3C web payments group. We are trying to integrate Bitcoin and Lightning payments into more of the web flow for payments, such that you can actually go out and buy stuff on normal Amazon and web shops. There's the WebLN integration that is done by Will. He will probably talk about this later. And we have payment gateways and exchange integrations coming up. And just a small teaser, we will be having a public Lightning specification conference later this year in Berlin. So keep your eyes open for the announcements when that is going to happen. OK. So this is a graphic that I showed last year. This is basically the state of the network back in May 2018. And you will notice that I have question marks when it comes to transactions and fees. Because remember, transfers on the Lightning Network are private. We don't really know what happens in a Lightning Network. And I'm claiming that's a good thing. What we can see is the size of the network in terms of participants that are running a node and number of channels, and of course, bitcoins that are in the Lightning Network currently. So these are bitcoins that are used to transfer payments back and forth in the Bitcoin network. And I ran this same script creating this graphic last week again, and this is what it looks today. So it got a bit brighter. I actually had to tune down the brightness of the lines a bit, otherwise we would just be staring at something yellowish. And from 1,700 nodes, we jumped up to 8,300 nodes. From 6,000 channels, we jumped up to 38,000 channels. And from 20 bitcoins, we jumped up to 1,100 bitcoins. So what we can notice here is that we have a 4-fold increase in the number of nodes in just the last year. We have a 6-fold increase in the number of channels. And we have a 50x increase in the number of bitcoins. So this is really good news for the Lightning Network, because what this shows us is that the network is not only growing, but the network is growing tighter by each node having more channels with other peers. And people are actually also getting more comfortable with using Lightning because we only have a 6-fold increase in nodes, but we have a 50x increase in the number of bitcoins in here. So whatever, if you've heard last year about capacity issues in the Lightning Network, this is basically addressing that. And again, we don't know how many transactions and how many fees are collected because, well, privacy. OK. So where are we going from here on? And this is basically the part where we talk about the Lightning specification meeting that we had last year. So this is a couple of improvements that we agreed on implementing for the next version, and I'd like to especially talk about the first 3, which are really exciting for me because splice in and splice out basically allows you to have funds in a Lightning channel and perform on-chain payments from those funds. So. And it also allows you to have on-chain funds and move them into an existing channel. So what this allows us to do is basically remove the separation between on-chain funds and off-chain funds. So I can basically have a wallet that basically just displays a single balance, and I don't have to care anymore about, oh, I want to do a Lightning payment, but I have 0.1 bitcoins in Lightning and 0.4 in on-chain funds, and I want to pay 0.2. I can't do that with Lightning payments, right? Now I can have all of my funds in Lightning channels and still be able to do on-chain payments. Multipath routing is the second part of this. It allows you to basically forget about who you open channels with and what capacity to do and how you choose your neighbors. Because multipath routing basically allows you to split a single payment over any number of channels that you might have. So what this allows you to do is have 10 channels open, removing single points of failure in your peer membership, and bundling the capacity of all of these channels into single payments. So instead of having one big channel of 1 Bitcoin to a peer, I can have 10 0.1 Bitcoin channels with 10 peers. Now, if one of these goes down, I still have 9. And I can still perform any payment I could have done with the single big channel. So this allows us to forget about channels and how we allocate them. And the last part is that I think I have them in a different order. But anyway, these two features basically allow us to simplify the UI of the Lightning wallet in such a way that all you see is basically a single balance. We will handle the channel management in the background. You see a single balance and your transaction history, and you don't have to care about anything behind it. So what this allows us to do is basically hide all the complexity that currently you have to learn and have a really simple interface that you can show your parents, you can show your brother, you can show your kids, and you don't have to tell them about capacity, you don't have to tell them about channels, you don't have to tell them about routing. It's all done in the background without you having to do anything. In addition, we have some really, really amazing stuff coming up, and we are actually discussing this later today. The multi-frame proposal is going to be merged today, if I'm not mistaken. And that allows us to do spontaneous payments and trampoline payments. So if you've ever heard about Lightning, you might have heard that routing is hard. Because I, as a node in the Lightning network, have to know, should not stand that close to that one. I, as a node in a Lightning network, would have to know the layout, the topology of the Lightning network to find a path from me to my intended recipient. And that's kind of hard. I actually have to download the entire network view, and I have to compute routes on my mobile device, maybe. That's going to take time. And what I can do now is what we call trampoline payments. Basically, what I have to do is know a path to a peer, and I will tell that peer, hey, I want to reach that point somewhere there. I don't know how to, but please, you compute a route for me. So I can delegate the route finding in a way that does not reveal to the person computing the route who I am. And I don't have to know myself how to reach my final destination. And we have some more features. I just grabbed some of the more interesting stuff, but the list is actually like 70 or 80 items. So if you want to get involved in this, please do. There's so much to do here. So I think that's it from me. Again, if you want to see a really amazing video about the Lightning Torch experiment, go to Tai Kawamoto. He has an awesome video. I have been Christian Decker, and find me on Twitter at Snike. And if you have questions, I think we don't have time for those, maybe later. Otherwise, just come and find me. You're up, man.
Our next speaker has been in the Bitcoin community for quite a very long time and is an outspoken voice for Bitcoin Core and its future. With that, I'd like to give it off to Pierre Rochard, who will be continuing the conversation on Lightning.
Okay, I'm Pierre Rochard. You can find me on Twitter at Rochard. I've been debating with altcoiners and no-coiners since 2013 on the internet. Started on Facebook and then went to Reddit, and now I'm on Twitter. I'm an accountant turned software developer. And why am I interested in Lightning? So Lightning doesn't have anything new from the point of view of monetary economics, which is kind of my background and what I'm most interested in. You're still using Bitcoin. It's still the 21 million Bitcoin cap. It's still sound money. So what interests me about Lightning is that it presents a better user experience than using on-chain Bitcoin for 99% of payments that people are going to be doing with Bitcoin. And it's also just hands down the best Bitcoin scaling solution. Maybe someone will come up with something new over the coming decades and centuries, but right now it's really all about Lightning and off-chain payments. So I founded Lightning Power Users this year to help onboard the next wave of Lightning First users and developers. And our first product is the Node Launcher, which is a Lightning desktop application. So why desktop? I've had a lot of this question. There's kind of this myth that everyone's only on their phones today, which I understand why it exists, because a few decades ago, 0% of people were on their phones, and everyone was on their computer, their desktop, or their mainframe, or whatever it is. But the reality is that it's more 50-50. Half your time is going to be spent on a laptop or a desktop, half the time on your phone. And I found that there were a lot of people who were optimizing for the mobile experience on Lightning, and there was actually surprisingly little going on for the desktop experience for Lightning. Another myth is that running a full node is not for mainstream users. And I think that the reality is, if you go into your computer and you look at all of the system processes going on in the background, there's a lot going on that you just have no clue what it's for. You know, whether it's you're on your laptop and it's like a battery monitoring system, like these things all just work in the background, and the user doesn't consciously think about them. And that's the way it should be for a Bitcoin node and a Lightning node. But there are real problems and challenges on the desktop. One, you have to go manually edit configuration files to set yourself up on Lightning. And you have to go in the command line to launch your Lightning node. And then you've got to do maintenance tasks to keep things humming along. The solution is the node launcher. It's a graphical user interface. It sits in your system tray, as with any other kind of background application you might have on your laptop or desktop. And all you have to know is that there's just a green dot there, which means that it is ready to go and ready to send and receive Lightning payments and open and closing channels. So the node launcher is cross-platform. It works on Windows and Mac OS. If you know the command line well, which you would if you're on Linux, then it'll work on Linux as well. But out of the box, it's for really beginners who are on Windows or Mac OS, not really for the command line wizards. In the background, you have Lightning Labs LND node running and the Bitcoin Core full node. So this is, with all due respect to C Lightning and their team, this is the node that I found easiest to work with, especially because it is cross-platform. So LND does work out of the box on Windows, Mac OS, and Linux. And likewise for Bitcoin Core. Bitcoin Core was an easy decision, considering the quality of the software engineering that goes into that project. The node launcher has 2 wallet UI integrations. And so because the node launcher is working in the background, you need some kind of way of interacting with it, with a front-end interface. And those are provided by the Zap desktop application, which connects to the node launcher, and the Joule browser extension. And so this allows you to use the same Lightning wallet with different UIs that might have different features that you're looking for or different use cases. So the Joule browser extension, which will be discussing later, that's really optimized for sending payments within your web browser, which I think is probably where 90% of payments happen anyway. And the Zap desktop application is great for manually managing your channels if you really want to get hands-on. I've gotten a lot of excellent feedback about the node launcher. People really do find it to be incredibly easy to use. It's just a double-click application that you open, and it just runs. It's fast. You don't have to wait. If you're ordering hardware, you don't have to wait for shipping to arrive in 2 weeks or anything like that. You just download the software, and you go. It does require currently syncing with the entire Bitcoin blockchain. So that can take anywhere from 6 hours to a week. But that really is going to depend on your internet connection. And it's free and open source. So that's a huge advantage as well. If you are a developer, and I actually built this to scratch my own itch. Despite being a Python developer, I don't like being in the command line. I prefer graphical user interfaces a lot. This really, I created it for myself, but I've had a lot of other developers jump in and help out. So I actually had an open source community member integrate Tor, which now you can be private by default when you're using Lightning and Bitcoin, which is a huge advantage. In the future, we're going to integrate light client technology called Neutrino/BIP157. What this means is that you will no longer have to wait 6 hours to a week for a full Bitcoin sync, because it will use the Light client as a stopgap and allow you to onboard onto Lightning in seconds while your full node is syncing in the background. Once the full node is done syncing, it'll transition from using a Light client to the full node. And that all happens without any kind of user intervention, which is really nice. And another thing on the roadmap is hardware wallet integration. So you'll be able to plug in your Trezor, your Ledger, your Cold Card, and it'll give you a notification of, hey, do you want to transfer some coins from cold storage to your Lightning hot wallet? Very excited about that. Do we have any questions? Oh, awesome. I'll leave it to the next speaker then.
Hey, y'all, sorry. A little bit of last-minute reorganization of the talks. So we've gotten to hear from Christian about kind of the topology of the Lightning Network, how it all works. Pierre just told you how to run a node, so none of y'all have an excuse today to not go home and start running your own node. And now I'm actually going to talk about kind of the fun stuff with Lightning, so we know how it works, we know how to use it, but what does it look like to actually use it on the web? So a little context about what I do. I work on a browser extension for the Lightning Network. It's called Joule. You plug your node directly into your browser, because typically payments, you're either doing it on the command line or through a desktop application or a mobile app. And so to tighten that up, we want the experience of where you're paying to be where your Lightning node lives. So let's talk about what Lightning apps look like today. So Lightning payments are done through exchanging invoices and then paying to those invoices. So typically, in a payment, for example, here on the right, we see Bitrefill. Bitrefill provides you with an invoice, and then the user pays to that. Invoices are very cool compared to the way of transacting with Bitcoin, because invoices have built into them a fixed amount, where they're going, an expiration time, and all sorts of other information. Whereas on Bitcoin, you typically just send to an address and cross your fingers. And if you overspend, underspend, you got to work that out with a human. So Lightning kind of smooths that out to where that cannot happen. Once those payments go through, as I'm sure you have heard about the Lightning Network, they settle nearly instantly. So you and the website can get on with what you're trying to do. You don't have to wait for an email confirmation after 6 blocks. You don't have to track yourself in the mempool. It's all happening in real time. Payments, though, can run into problems. We've heard a lot about routing issues today. Basically, if you cannot find a path from your node to their node, you're going to run into trouble. And something that's very tough with web apps today is that they have no information about that, because since you can't find the route, you can't really inform their node of the problem. So these routing issues are placed solely on the user. And they kind of have to debug themselves. So it's still early days, still a little rough around the edges. And then from a user experience standpoint, this still requires switching to some kind of external application or pulling out your phone, scanning a QR code, as you see here. So we're still putting up walls in front of payments. We're still making users very aware that they are about to pay. And so you can't really end up with these microtransactions that a lot of people talk about in the Lightning Network. Another thing that people are doing to run web applications is hosting custodial nodes. So here on the right, we have the wonderful Koala Studio, where you can play games online. They're a game studio. Right now, you can wager Satoshis in playing a game of chess. It's really fun. Definitely check it out. But the way it works with them, because they know this payment process is kind of annoying, is you do one upfront payment to deposit into their central node. The balance that you get from depositing there is tracked in some central database of theirs. Payments between users is handled in this database, not on the network. And then when you want to withdraw a balance, you provide the server with an invoice rather than the server providing you one, and they pay out to it. So this smooths out a lot of the edges of payments, but it really does not take advantage of the network effect of the Lightning Network. I should be able to route payments directly to people. And when you have all these websites that operate this way, well, your money stops being on your node and starts being in databases of a bunch of different services, so you don't get access to your liquidity on the network if it's locked up in every site. Those of you who use a lot of exchanges maybe have encountered this kind of issue where you want to, you want your money somewhere else, but it's locked up on another site, and you have to go through this process of withdrawing and then depositing to where you want to go. So Lightning is supposed to solve this by keeping it all on your node. But right now, to smooth out the user experience, we're not taking advantage of that. Another interesting side effect of Lightning is kind of a variable purchase permanence. So for larger purchases that you want to save and come back to later, maybe if you were renting a movie or something like that, you would still require some kind of traditional identity to log in so that they could associate your payment with an account. But some purchases on Lightning are so cheap that they are tied directly to your device, and they can't be transferred. So on the right here, you see yalls.org. It's kind of a pay-to-read articles website that I think the price is like 100 Satoshis, which is under a penny. Well, the market's been doing pretty good, so maybe it's over a penny now. But the way it works is that it gets saved into your browser's local storage. So you can see I purchased it on the desktop. I can read the full article, but if I open it on my phone, it's going to hit me with that paywall again. Because the payments are so small, people aren't really focusing a lot on how to save your payments. And some purchases are so small, they're completely ephemeral. So once you browse away or you refresh a page, your purchase is gone. It was kind of a one-and-done use. So this can be a little confusing to users who maybe come back later or in a different browser or on a different device, and they can't really understand why can't they access their content. So in summary, if you're making a website, a lot of elements of using a traditional payment method over Lightning, it's still the same. Making payments is still pretty high friction, and in the case of routing issues, it can be even more so problematic. So we're not winning on that front. Payments between users typically is still managed centrally, so we're not promoting decentralized use cases if every website is running their own custodial node that you pay to pay between users. Micropayments are still not a viable user experience. So one of the things that people talk a lot about Lightning is these streaming or micropayments where you're just kind of paying for every little bit that you use in very small amounts rather than these upfront large costs, which can be kind of a bad user experience. But if you're stopping the user along the way, they're going to bounce from your site. They're not going to stick around. And once they make those purchases, we're still using traditional login of username and password or OAuth to save those purchases. So users, they still have to revoke a little bit of privacy to stick around on your website. So I'm trying to address some of that with a spec that Christian had mentioned earlier called WebLN. The idea here is just to make the web experience more integrated with Lightning. So what is WebLN? It's a standard for providing permission access between a web app and your node. So it facilitates communication in a permissioned way to where a website can ask to do things with your node. The user's client injects a little bit of API into JavaScript, that the web app can access, and then it can request access to your node. It informs the user of this, and the user can grant permissions. So we've got this improved user experience where people can directly interact with the node without compromising the security or the privacy of the user. It's off by default. They have to allow for it, and they can kind of specify what permissions a website gets. So if you're familiar with the Ethereum world, there are some similarities here to Web3. And certainly, I owe a lot of credit to the MetaMask team for the interactions and design of Joule. But it definitely comes with more of a Bitcoin ethos to ensuring that users are in control of the experience and that websites can't access things before we've allowed them. So one thing we get out of this is in-app interactions. So here you can see a purchase on the aforementioned yalls.org, and I'm never leaving the application. There's an API interface here that allows the payment to happen without having to leave. I don't have to Alt-Tab to another application. I don't have to pull out my phone. I don't have to copy and paste these lengthy invoice codes. If something were to go wrong in a payment, the WebLN API can inform the website, and they can try to help out. So if they see that there's a routing issue, they can pop up their node's information and say, hey, here's how to open a channel. Here's how to get some liquidity to my node. Right now, it's just a totally blank experience. The payment fails, and you don't know what to do next. And this is lowering the friction of payments so we can get closer to that micropayment structure that we've talked about. This also enables the peer-to-peer use case a lot better. So by automating that invoice generation that allows people to pay you, you can easily facilitate peer-to-peer payments between your users. So before, the server would hold the balance, so the user on the left would send some Lightning to a central node, and then the user on the right, when they eventually wanted that money, would send an invoice to the server, and the server would send Lightning out. And so there's all this liquidity captured inside of the central node. What we can have today is that all the server does, it does not even need to run a Lightning node. So if you're wanting to experiment with Lightning, but you yourself don't want to run a node, you could still create an application that just facilitates the communication of invoices between users. And so the payments are going through the network graph. They're not going through your node. So users can pay each other directly. You can also have your node provide its identity and proofs about things that it can prove. So users could opt in to provide and prove their node identity and use signatures to ensure that it is actually you, it's not something reporting to be you. They can also provide old payment proofs, because whenever you make a payment on the Lightning Network, you save this thing called a pre-image. And that pre-image is a proof that you paid for something. So you could have your node offer that up to websites to recover past purchases. This is also can be used as a free and Sybil-resistant auth option on your website. So if you want to prevent spammers, you want to prevent people who aren't actually good actors on the network, you can have them provide their node's information, prove who they are, and you have a unique identity. And unlike addresses on a blockchain, it is not trivial to spin up a Lightning node, give it public connections. That costs time, it costs money to set up channels. So this is a good option if you want to kind of have a pseudonymous identity that users can't attack your website with. And by knowing who a user is on the network, you can encourage and reward them for helping you in the network. So perhaps a user who has a channel open with you that they're providing liquidity, you could give them discounts on your products because they're offsetting some of the cost you might have to make to set up that liquidity. So it's kind of this very community-driven approach that still respects levels of privacy and anonymity. Something that's still kind of in the works, but by having an API we're enabling, is a confirm free experience. So the idea here would be that your client would configure an allowance for payments and invoices without interacting, the user having to intervene and say, OK, yeah, make that payment. The app could request allowances up front, so you could imagine if you're going to stream 10 minutes of video and you want to charge user every 10 seconds, that you just set that allowance up before you start, and then the payments are happening in the background. So this unlocks the ability for these micro and streaming payments that people talk a lot about. Another very interesting thing by facilitating communication directly is that we can program our nodes. So nodes are really cool because they're just APIs that you run in your own home or wherever it is that you run your node. And those, that web server that runs that API can be programmed like any other. So for example, LND, which is one of the implementations of Lightning, uses these things called macaroons, which you can think of as like fancy cookies, like browser cookies, that give permissioned access. So on the right here, we have this app that I just launched last week called TipHub. The idea here is it's a non-custodial tipping service. I provide that service with a macaroon that only allows it to generate new invoices, so it can't send money. It can only set myself up to receive money, and users can tip me directly, whereas other people have had to go through custodial services that hold tips or whatever payments for them. This facilitates a direct payment to me without me even being online to generate the invoice. So with a macaroon and an IP address or whatever option we use, you can end up with all sorts of program payments, such as subscriptions or pay per use. And all of the above of what we just talked about is totally client agnostic. So of course I had to show off my own extension, Joule. But there are applications and other extensions out there. For example, here, Blue Wallet on the right. So a majority of the interface is provided by the client rather than the web application. So you can spend more time building your app and less time trying to facilitate the user payment. And this can be used with any Lightning node implementation. So it's not limited to LND, as I mentioned before. It could work with C Lightning and Eclair. The spec is open. So we already have extensions and mobile apps today and more coming. So I was told there would be some developers in the audience. I'm going to show a little code of just what it looks like to implement WebLN. But don't get too scared. It's a very small amount of code. There's some pictures, too. So it comes in the form of a library or a script that you drop into your page. It's very small. This does not provide a lot other than facilitating the communication between the app and the browser. So you request a provider from the user. It's just a few lines here. And the user is then prompted to either confirm and allow a little bit of access or to reject. At this point, the app can ask you to do things, but it can't do them without your consent. To send a payment, once the user has accepted, we just run this function and pass it one of those invoice strings. That's it. There's not a lot of back and forth here for the app developer. And so if the user didn't have an allowance configured, it might pop them up with something that looks like this. Once they confirm, the application will be aware that the payment has gone through, and they can start watching it on the network. If they did have an allowance set up, though, you wouldn't even see this. The payment would just happen. Users can also have invoices generated on their behalf. So here's a fixed amount invoice where we're saying, please give me 500 Satoshis for some reason. You can also specify more about invoices. So here we're saying somewhere between 100 and 1,000, and also attach this little message to it so I know what I'm asking for payment. So when you go back through your records, you can see why you got a payment. And it'll pop up something like this. Again, this could also be happening in the background if a client configured it that way. What happens if a user comes to your website and they don't have a client? Well, that's actually not a problem. So a lot of people who have interacted with, like Ethereum dApps, and it stops you and it says, oh, you have to install MetaMask, you have to install something else. You can actually facilitate payments even for users who don't have those clients by using a little thing I wrote called React WebLN Fallback. The idea here is it's a very simple React component that you can just drop into your application if you don't use React. There's a standalone version as well. And what it does is when you make these WebLN calls and the site detects that you don't have a client, it just pops up some instructions for how you might handle this if you're a node user who runs your own node through the command line or who runs it via a desktop application. And it's pretty visually agnostic. It comes in all sorts of different shapes and sizes depending on which UI libraries you're using. And it comes with all of that written. So again, kind of the goal here is to make you spend less time trying to reinvent building a wallet interaction interface and more time building your Lightning applications. If you're interested in making your own provider, that is also quite straightforward. It's pretty much 3 straightforward steps. You want to leverage some kind of existing browser or create your own. So you can either create an extension like I did. You can do a mobile app with a web view similar to Blue Wallet, or hey, you could even fork Chrome or fork Brave or create an Electron browser and provide it that way. You create this provider object that facilitates the communication between the node and the web app, that matches the spec, and you just throw it into the page before the page gets started. If you're a TypeScript developer, which you should be because it's an amazing language, there are types provided to make sure that you write the spec compliant to how other providers work so that yours will work agnostically. So whether you're using Joule, Blue Wallet, Bitlum, any of the other providers out there, the user is going to get the same experience. So thanks for listening to my talk. If you are interested in getting started on WebLN, I've got some good documentation. Or if you just want to try out what it is like to use it, you can check out Lightning Joule. If you're interested in contributing or you have any questions for me, feel free to reach out. There's my GitHub and Twitter. Thanks, y'all.
Thanks a lot, Will. Great stuff. So we have our next solo presenter coming up, and our last solo presenter for Lightning, Jameson Lopp. We're going to bring all the speakers back on stage after, and they're going to do a little panel. And this is also a public service announcement. So in the room across from here, we have a session called Changelog, and it will be going on for the next 3 days. Think of it as sort of rolling shareholder meetings. You'll have over 25 different platforms. They'll be offering 10 minutes on their financial updates, so how much tokens are in lockup, what's been invested where. They'll do 10 minutes updating their roadmap, and then Masari will be facilitating 10 minutes Q&A. So if there's something in a bag that you don't like and you want to go curse at them, you can go over there and curse at them. Just look at the agenda and you'll find out when these different platforms are going. And they'll be starting at, I think Elixir is first up with David Chaum, and then we'll be going to Ion and several other platforms afterwards. So next up, we have Jameson Lopp.
So today, I just wanted to give a little overview of what we've been working on at Casa, specifically talking about our plug-and-play Lightning node. Does anybody here happen to have a Casa node? All right, hopefully a few satisfied customers. And if you do have a Casa node and there's anything you think is missing, anything you're having problems with, we're a very feedback-driven organization. This has been a very fast-paced development over the past few months where we've been learning as we've been going. So just going to talk a little bit about some of the functionality that we've built into it, some of the challenges that we've faced and overcome, and hopefully these things that we've learned will be helpful for any of you who are also building Lightning-based services. So one of the tenets that we're trying to achieve at Casa is usability, because I suspect that you've gotten a good idea, if you hadn't already from some of the earlier talks, that the Lightning network and this second layer protocol is extremely complicated. So there's a lot of work that needs to be done, not only to get this Lightning experience working in a robust way, but also working in a user-friendly way so that we can abstract as many of the complexities of these protocols under the hood and just have a nice, shiny, point-and-click user interface that people can interact with. So at Casa, what we decided to do when we were trying to figure out how we could continue to further our mission of improving personal sovereignty, we had already built a key management app. We figured the next obvious thing was help people run their own full nodes so that they can have the strongest security model that you can have on these networks, which is because you're not trusting anyone, you're verifying everything that's happening yourself. But I've been running full nodes for probably 6 or 7 years, and this is not a very straightforward thing. It's kind of a big ask for a normal person, because what we're asking people to do is to become a server administrator. And a server administrator needs to know a number of different things, not the least of which being networking complexities. How do you set up port forwarding and firewall rules and all these other complex security issues that happen once you place a computer out on the internet that is now potentially open to a variety of different attacks. And really, most people don't want to deal with these day-to-day IT issues of, oh, my server went down, what am I going to do now? So what we tried to do was make this as plug-and-play as we could, and one of the ways that we did that was we Dockerized all of the different services that are required to get one of these nodes up and running. And that gives us a number of great attributes, one of which being, we can configure how these services come up automatically, we can manage helping the user update them, and we can more gracefully recover from a number of edge cases and error conditions. So there are still a lot of things that can go wrong when you're running Bitcoin and Lightning nodes, and thankfully, in most of the edge cases where something does go wrong, we can generally tell the user to just turn it off and turn it on again, and hopefully that will fix everything, as long as you haven't had a terrible hardware failure. So we've got a number of different services we're running, of course, Bitcoin, Lightning, some of our own middleware services to make the API development easier, and then, of course, we've got a slick front end that I'll be showing you in a bit. And behind all of this, though, are various service management services, some of which kind of maintain the health of the current services, and then another which takes care of making sure that we're running the most up-to-date versions of services. So when you log in to the Casa node, you'll be greeted with a fairly simple dashboard. We try not to make things too complicated. You've got Bitcoin, you've got Lightning, and then you've got other service-related functionality. If you're going into your Bitcoin node manager, we give you just a few high-level things to try to give you an idea of, is your node online, is it healthy, is it talking to the network, is it synced? And there's really not too much else that you have to do, unless, of course, you are particularly dangerous and you want to resync a bunch of data from scratch because perhaps you don't trust us. And that's perfectly valid, though it would take you a few months to do so on the current hardware. Bitcoin Wallet is also fairly simple because we're really more interested in the Lightning functionality here. We just want to make it very easy for someone to deposit funds and withdraw funds on chain, but really the more interesting stuff is on the Lightning side. So once you go in and you're managing your Lightning node, at the moment we do have to present some information that I hope in the future we no longer have to, but we give you some information about your channels, their liquidity, whether you have any payments or any channels that are currently being opened. But while we do give you the ability to do your own manual channel management, the main reason you would want to do that today is because the understanding of how liquidity on the Lightning Network actually works is under active investigation. People are still learning a lot about how we're going to do liquidity management. So I think Pierre, for example, has done a lot on the liquidity side and has shown that as of today, if you're sophisticated, you're putting in the time, and you're actually managing your channels yourself, you can probably do a lot better than the autopilot, which is something that we have featured. But I'm hoping that the autopilot really does become more of a plug-and-play thing where all you have to do is click on it, enable it, and give it some money, and we'll be able to automate a lot of the liquidity management that is currently being determined manually by people. So in autopilot, right now we just say, how much money you want to put in it, how do you want to spread it out. This is kind of more important right now because the way that liquidity gets spread around is more important because we don't have like atomic multipath payments. We don't have the ability yet to send payments that are like parallelized through multiple channels. So unfortunately, the way that you have your liquidity dispersed across channels can make a difference. But once you get into the Lightning wallet itself, of course, you'll have your send and receives. And once again, as a result of not having this ability to make atomic multipath payments, we do have to present some information to the users about their maximum incoming and max outgoing payments, and that's because, like I said, they are limited on a channel-by-channel basis. Unfortunately, it's not as simple as saying, in aggregate, all of your liquidity incoming is this and outgoing is that. And even years in the future, hopefully we don't even have to display any of this information at all. People are working on various technologies to make channel splicing, submarine swaps, various looping in and looping out technologies that the folks at Lightning Labs and elsewhere are working on, so that I'm hoping that over the years this distinction between on-chain funds and off-chain funds kind of fades away, and we can once again hide more of those complexities under the hood. On the networking side of things, though, this is something that I'll talk more about in a few slides. We do have the ability to turn on and turn off Tor on both the Bitcoin, Lightning, and the actual dashboard itself. And this has been important for a number of reasons. We spent a lot of time working on Tor integration, and not just because we're cypherpunks who think privacy is a cool thing. In addition to having the Lightning on Tor, which is important because otherwise you're basically giving away your public IP address to a number of different entities, the ability to actually reach your Casa node externally over the network is something that Tor enables for a number of different reasons. The only downside that we've found to Tor so far is that because there aren't a lot of Bitcoin nodes on the Tor network, syncing your blockchain data can be kind of rough. So we're generally leaving the ClearNet Bitcoin node operational just because we found that it can fall behind on syncing if you're trying to do Tor only. But this is another thing where over the years, I think that as more and more Bitcoin nodes are joining the Tor side of the network, we will have better connectivity and faster syncing. So under the system settings, one thing that was tricky for us because we are very privacy oriented is that we don't have any analytics in our app. We don't even have any crash detection or anything that phones home to Casa to aid our developers in debugging stuff. And this is because we don't want to accidentally leak any data from the user. So this is a more manual process, but if something does go wrong and you call up Casa, then we'll generally tell you, hit the log download button, and that will actually download and PGP encrypt your log data so that only a select few Casa engineers can open that up. Now, in order to make the node more usable, we also developed a browser extension quite similar to Joule, as you saw earlier, where we wanted you to be able to just seamlessly from the browser be able to connect to your node and use the various Lightning functionality. If you're in a situation where your computer understands the .local DNS and you're on your local network, you don't even have to know your IP address in order to connect to your node. You can just, I think it'll actually automatically look for the Casa node.local, and you just put in your password and you'll get your interface to come up. So then if you go to a service, especially one like y'all's where it actually has Lightning invoice buttons, then you can skip over some of the more annoying copy-paste requirements of getting that huge encoded string for the invoice. All you have to do is click on it. The browser extension will detect that you're trying to pull up a Lightning invoice, and it will just load it into the browser, and with basically 2 clicks, you will be able to make that Lightning payment. So the reason why Tor, I think, is very interesting, and I haven't heard too many people talk about it, is that it solves a lot of these networking complexities that I mentioned earlier, where what we're trying to do is get people to be sovereign unto themselves, which means that they need to be running their own services, but we can't expect users to be technically knowledgeable and able to do that. So some of the things that we tried over the past 6 months in order to get around the complexities of home router networking management is we tried using universal plug and play, which is something that will automatically set up your port forwarding for you. And we found that that works in probably less than 50% of cases. It really depends on what router you have at home. And more surprisingly, what we found was that even in some cases where it would work and the user could just plug in their device and automatically be able to talk to it from outside their network, sometimes it would just stop working. Perhaps because the internal IP address of the node changed and universal plug and play didn't figure it out. Sometimes we even found that universal plug and play was creating many, many different entries, and it seems like it got confused, and it's not really clear why that was happening. So we basically determined that that was not reliable enough to ensure a good user experience. We also found that the .local DNS that we set up to try to make it easier to initially discover your device is very dependent upon browsers and operating systems. And of course, the whole port forwarding thing, significant amount of our support time that people have called into us has been simply because, oh, my node can't be seen by the rest of the network. And the problem there is that there are hundreds, if not thousands, of different home routers out there, and they all have different interfaces for how to set up port forwarding. Some of them are easier to figure out than others. And another thing that we did get a lot of flack on, and rightfully so, is that we were not encrypting our traffic to the web dashboard. So a lot of people were a little upset and calling in and saying, hey, my browser says that I'm submitting this password form over an unencrypted connection. And so we had been telling people, only use this in your internal network because it's not safe to send your credentials over the internet unencrypted. And the reason that we did that is that we were playing around, of course, with doing self-signed SSL certs. But when you do that, a lot of browsers complain. So it was kind of a lose-lose situation of some browsers complaining about unencrypted authentication, whereas pretty much all browsers would complain about trying to do authentication encrypted for a self-signed certificate that was not known and trusted by the browser. We also looked into some of the options for creating your own, trusted self-signed certs, but then that would have required us figuring out some sort of DNS solution, which likely would have been centralized and created a single point of failure with Casa. So also found, some users had public IP address rotations that were unpredictable and caused their node to no longer be reachable at a certain address. More interestingly, we found that a number of users didn't even have a public IP address at all. This could be because they were behind a large institution like an enterprise or university, or in some cases, even we found that some residential ISPs do not give you a public IP address unless you pay a premium on your monthly bill. So what we ended up doing is we implemented Tor, and the reason that we did that is that it allowed you to punch through all of these networking issues. You no longer have to worry about getting through the router, setting up port forwarding. You no longer have to worry about an SSL cert because it encrypts all the traffic automatically. The only downside is that it means that the user has to get a Tor browser. But I think it's a lot easier to go to the Tor browser page, download it, and run it than it is to figure out how to do all the networking complexity. So we've found in general that users find that to be a more pleasant experience. But in general, this is still a very reckless area to be working in. There have been users who have lost money due to hardware failures, software failures. There are, I think, some issues where even though we warn the user on initial setup not to put more money than they might want to lose into it, I think some of the semi-sophisticated users, they see, oh, I have my recovery seed here, so as long as I keep my recovery seed safe, then I can get all my funds back. But that is actually not the case in Lightning. The recovery seed is only for the on-chain wallet, and we did, of course, get static channel backups with the latest LND release, but even that will only allow you to recover your initial channel openings. You won't be able to recover every single HTLC, by which I mean every single time your channel updates, that creates a new HTLC. So in order to actually get the entire state of your Lightning wallet, you actually need to have dynamic channel backups, which basically means you're freezing your channel data each time you update it and making an off-site backup to some other place. So that's also something that we're working on, though we have the static channel backups. I think if they didn't get released in the past few days, it should be going out in the next release. So main point being with all of this is that there's still a lot of complexity in Lightning, especially a lot of complexity that needs to be abstracted away. And that's because we're building this for a mainstream audience. One of the bigger challenges at Casa is that a lot of our users are early adopters. They're technically sophisticated, and they're asking us for a lot more advanced functionality, but we actually have to push back on that because they're not necessarily our target user in the long term, and we don't want to overcomplicate the user experience. So thanks for listening, and hopefully we can get some more interesting chatting going on right now.
Hey everyone, so with that we're going to do a panel discussion on Lightning, and we'll take one or two questions after we kick it off. So Lightning is quite an exciting thing, and we're very grateful for you to have given us an intro to it. I guess one of the things we could discuss first, what do you think is one of the largest commonly held misconceptions or beliefs about Lightning? We could ask one or two more questions and then do some audience questions. So I don't know if you guys, what is the misconception or belief that you think currently you think Lightning people don't know about Lightning, or that people currently hold about Lightning that you think they should have greater understanding of?
That's hard to decide. I think there's quite a few smaller misconceptions. There's no huge misconceptions that I can think of, but yeah, coming from an academic background, maybe the one that irks me the most is that that routing is NP complete, which is so not true. It's just not. NP complete problems are usually optimization problems where you only accept the optimal solution. Routing can work with non-optimal solutions. So not NP complete, not a knapsack problem, not a traveling salesman problem. It's solvable, and we've solved it so many times before.
So for those of us without the doctorate, that's like another 20 minutes to just unpack that statement?
Yeah, the claim usually is that routing is impossible because, well, it's really, really compute intensive. It's not. That's the main issue, I think. So that's my favorite one to debunk.
Is this mic working, or should I use? Okay. The biggest misconception I see is that people think that Lightning is just for micropayments. So like for sending fractions of a penny around. The reality is that you can send fairly large payments even today, even with a network that has very little liquidity compared to where it will be in 5 or 10 years. So today, you know, I see payments getting routed through that are hundreds of dollars, you know, frequently. I don't know if they're paying themselves or if it's actual use in commerce, but I think that you'd be able to speak to that more. I think that's the biggest misconception, and I think that the reason that you want the ability to send larger payments on Lightning is because over the coming years, we're going to see the mempool, we're going to see on-chain transaction fees continue to be volatile. We saw a particularly volatile period during the previous bull market in December of 2017, where people were freaking out about having to pay $25 or $35, whatever it was, to send a Bitcoin transaction on-chain. And I don't think that's, we're going to get back to that point, and on-chain fees are going to continue to not only be high at some points, but also just be going up and down a lot. And what Lightning allows you to do from a user experience perspective is smooth that out. So you open a channel when on-chain fees are very low, and when on-chain fees are high, you're still able to send value around without having to pay those very high on-chain fees, because at that point you're off-chain. And then you can wait until the fee market has gone down or stabilized if you want to close a channel or open more channels. So it allows you to defer settlement opportunistically until it makes sense from an economic perspective. And I think that people doing that, arbitraging between periods of low on-chain transaction fees and periods of high on-chain transaction fees, is actually going to dampen the volatility. And I think that that's what I find really fascinating about Lightning from a economics perspective.
Yeah, I agree that that's a bit of a misconception that you know, we always had the ability to do microtransactions in a centralized way, and they never took off. So why would they take off now that we put them on a blockchain? That's how I see it. But my favorite misconception, to put it in the context for developers, is that the Lightning protocol works like the Bitcoin protocol, like the base layer, and it doesn't. Like 3-4 times this weekend at the conference this weekend, I overheard conversations, or was part of conversations where people were asking, when is the channel size limit going to be upped? Like, when are we going to raise the block size, you know? And the answer every single time was when Lightning Labs says it's ready, when it's time. And that's not how Lightning works. You can actually change any of the rules, and you only have to be compatible with the part of the network you're trying to connect with. That can just be one person. It's because channels are just a relationship for two parties. And so I think that I want to make sure the developers are thinking more about this dynamic, and the fact that it's going to allow you to create products and features in Lightning that might not come from the main laboratories that are working on Lightning. It can be a guy in his basement. He just figures out he wants to do this thing with Lightning. He gets some wallet that's somewhat popular to make it compatible, and now all of a sudden everybody is going to Lightning Labs saying, hey, how come your wallet doesn't have this feature? How come I can't do this with your wallet? And then the protocol gets driven by the marketplace instead of from what interests developers.
I think for me it is the biggest misconception is that Lightning is for Bitcoin. I mean, Lightning certainly is for Bitcoin, but Bitcoin has seen the fastest adoption and the most development effort on it because Bitcoin is the chain most in need of it. And I think that's actually kind of a boon to having these tight constraints on your layer 1 is that you come up with these very imaginative, elaborate layer 2s that are much more extensible. But Lightning is not limited to Bitcoin. It is chain agnostic. All of the research behind it could apply to any chain, and interoperability is important to the Lightning Network. It's something that's being designed in, in some cases consciously, in other cases it's just a simple byproduct of the way it works. And so when people say the Lightning Network is the future of Bitcoin, I like to think that the Lightning Network is just the future. Any chain that runs into scaling problems, the same way that Bitcoin has, any chain that gets enough adoption or reaches its limits could easily implement the Lightning Network, and we could all live higher up on this layer 2 stack.
And as a sneak peek, the next speakers will be from Polkadot, which is a cross-chain method of token transferring. And most people don't know this, but Lightning actually had one of the first, I believe, cross-chain transfers, which was between Lightning Bitcoin and Lightning Litecoin. Sorry, tongue twister to say at the same time, Lightning Litecoin.
I think one of the more interesting FUD pieces that you see come out is that Lightning is inherently centralizing, and that it will, over the years, centralize to the point that it becomes a permissioned technology. And I can kind of see why people might think this, but I generally make a relationship to the internet itself. And the way that you get the scalability on these global broadcast all networks is you create routing so that you are engaging in more private or at least more efficient means of data exchange. So you can make the same argument that the internet itself is more centralized than it would be if it was only built on the Ethernet layer. Because we are routing data through a small number of parties, you could say, oh, it's more centralized than if data went through everyone. But that doesn't make it a permission technology. The fact that this is still voluntary interactions and that you can route around parties that are not agreeing with you or not playing by the rules, that is the more important part. And so I think that some people jumping to the conclusion that either due to liquidity issues or due to regulation issues or whatever, that Lightning is going to become like a bank technology, I think that is really taking a leap out there. It's a logical leap that I can't quite follow.
I have a question, which is in relation to the relay nodes and hot wallets and how we see exchanges. Recently, the exchange that asked for a block to be wound back so they could get their money back because they lost money from their hot wallet. How will Lightning relay nodes that are engaging with basically hot wallets secure or engage with Lightning? What's going to happen? Are we going to have some payment channel with 100 million, 200 million Bitcoin in there, and hear some angry person try to drum up the community to roll back a transaction because their Lightning relay node got hacked? Like, what's that future going to look like?
Well, I mean, that's still definitely a possibility, but first of all, I think that it is incredibly important that exchanges, if they're not already, they get into researching how to integrate Lightning. I think it was over 3 years ago, I wrote an article, a very speculative article about Lightning. One of the things that I said was that I believed it would be a scale-free network topology, which relates back to the centralization argument. And yes, there will be larger players and smaller players. But another thing was that I saw that A.J. Towns had done some simulations basically showing like long-term lived channels and networks of channels, and that it's much healthier for a network like this if you have liquidity providers, or specifically exchanges, that allow people to basically top up their channels out of band, through some other payment mechanism. So I think that exchanges will become very important. As a result, of course, they will become targets. Exchanges are going to have to continue developing their own security. And we'll have other security companies. I'm sure BitGo is going to be interested in trying to help exchanges with Lightning Network security, for example. But it will continue to be a risk-reward type trade-off where I don't think exchanges are going to put all their money into their Lightning wallets. It's once again going to be something where we understand that this is a riskier situation, and we need to figure out how to mitigate that risk so that we don't end up having these silly social discussions where we try to create consensus in a matter of hours across this globally distributed network. That's why the network exists, is so we don't have to have social consensus.
I also want to add that I don't think that Lightning makes it better or worse for the way exchanges work today. I mean, I think one thing that gets lost in the headlines is Binance only lost about 2% of their funds, because that's how much they keep liquid at any given time. And you can do the same with a Lightning node, where it is a small portion compared to your cold storage. And a lot of what, for instance, like Alex Bosworth is working on at Lightning Labs is the ability to loop out money. You remove some of your on-chain liquidity and put it into cold storage without actually affecting your channels. And so I think that you'll find exchanges come up with techniques to regularly dump out into cold storage to make sure that their Lightning nodes, or to get inbound capacity, to make sure that their Lightning nodes are as connected as they need to be to keep up with volume, but to also make sure that they don't become such a big target.
I think your question forgets a couple things about Lightning. One of them, the first one would be that the instantaneousness aspect of the transacting is going to make people less inclined to leave their coins in custody elsewhere. And so if they're on the Lightning network and they're holding coins on their side, they have control. They can close that channel at any time, or they can use that connection to the Lightning network to say deposit at an exchange that supports it instantly. So I think that you might see an actually improved security profile for the entire Bitcoin network, because people don't need to leave things in places because they can instantly put them there through Lightning. Another aspect I would say is, what was I going to say? The exchanges. I had a brain fart.
I've got things on my mind.
Yeah, you go ahead.
So I do currently run one of the largest Lightning routing nodes, and the way I see the risk is that there's different categories. One of them is just on the Lightning node software implementation level, and if there's like a bug in that allows someone to drain funds from my node, and that actually is the one that scares me maybe the most, but I know that there are very solid software engineers working on the protocol. I don't trust them, but I do have confidence in their software engineering abilities, and I think that will only improve over time as these implementations mature. Another aspect of it, though, is that currently Lightning nodes are incompatible with this generation of hardware wallets. So what I'd like to see is a hardware wallet that would essentially be a removable HSM and that can be signing transactions in a secure environment, and perhaps limiting it to a whitelisted binary like C Lightning or like LND. So that, and third would be kind of the the environment in which the node is operating. Because if I understood the Binance hack correctly, it was through their user interface that they were able to access the funds. And so if you're running an exchange, it doesn't matter if the backend is Lightning or Bitcoin. If people can log into your user's account and remove funds, and it looks like it's your users that are removing funds, well, that's a huge problem at a different level. And then lastly, I think the fourth biggest risk is social engineering. The way people get Bitcoins taken from them is by a slick salesperson pitching an altcoin. That's 99% of the theft of Bitcoins is how that happens. And it happens a lot at conferences like this. So be very careful about the conversations you have with people here. If they present to you an argument for why their altcoin is better than Bitcoin, be extremely critical and review the evidence, maybe have it peer reviewed by others so that you don't get your Bitcoins fraudulently stolen from you, because that's kind of how it happens, not really with a Lightning node getting hacked. Let's rewind.
You made a point about how, like, with the Binance hack, for example, it was done via the platform. And so one misconception I think about the way you formed the question is that you can actually disassociate your Lightning node usage and how it's participating in the network from your identity and from your platform in this aspect. So getting your Lightning node hacked kind of becomes like, well, how the hell did they even know it was you, and how did they get in there in the first place? And that's how a lot of hacks are. Like, it's not a weakness of the design of Lightning, it's a weakness of how you've incorporated your Lightning node into your activities.
Yeah, so I'd like to echo your point about giving people the ability to move funds back and forth into exchanges more quickly, and thus empowering users to actually take charge of their own funds more effectively. Because the reason why people currently leave funds on exchanges is because moving them in and out is cumbersome. It just takes time. You can't trade when you really want to. You have to plan ahead when you actually want to trade, and so this is why you enter this risk. And if you have a Lightning channel with the exchange itself, you can move in and out more quickly and at the point you need it. Now, I'm happy that you trust us, and I'm happy that you trust our engineering capabilities. But we're very aware about the risks involved in developing this software. This is also the reason why we added this informal limit on channels, because we didn't want people to put their life savings on top of it. And at the time we put in this limit, it was actually enough that we could basically give you beer and we'd be square. Now that's not the case anymore. Too bad. But yeah, we try to inform people very much about the risks involved, and we try to extend the confidence that people can have into the systems in a stepwise manner, such that we can actually reduce our own risk of losing people's money in the first place. So that comes in a social form, in the form of the reckless hashtag. It comes in the form of this informal channel capacity limit. And as soon as the confidence in the systems increases, we can definitely extend those limits as well. And if people want to experiment with more, of course they're free to do so. But I wouldn't want the moral sort of weight on me if people actually lose their kids' college funds on software that I wrote. Yeah.
We've talked about this before. Would you mind if I reply? We've talked about this before at other events, but I have kind of a more nuanced reply to it, which is that I think that worrying about the reckless aspect too much, it implies that Lightning will be done one day, and it will be safe, and like that one day we're going to say, okay, now you can do it. But the thing is that there'll probably be perpetual development on this platform, and so the users of it will probably have to understand that they're going to have to pay more attention and understand risk and what they're getting into in general. So like, when is it safe enough? Like, are you just always going to say, like, be careful, like forever? Like, you know? But at some point, we expect more and more people to use this. So if we keep telling them it's too soon, like there has to be a threshold that we break where we say, okay, maybe we just have to say, please understand the risks, but come on, come get on board,
And with that, I'd like to thank you so much for your time. And everyone, if we may join in thanking the panel. Yeah, well, thanks. So just to tail end it, if someone wanted to get more engaged with Lightning, what should be the sort of next step that they should take? And then I guess we can talk about Web3 next.
Talk to us.
Well, there you go. There you have it. Well, thank you again.
Did you want to?
Oh, sure. Why not?
Oh, okay. Well, I would say go download the Node Launcher. If you just Google Node Launcher, you'll find it, and try it out. Get your hands dirty.
Yeah, you can find me if you want to grill me on anything to do with Lightning. I'm Bitcoin Errorlog on Twitter, and I also work at Bitrefill, so you can come to bitrefill.com, and one of the services we provide is we actually sell Lightning channels. So if you need to get onboarded, we have a special Lightning channel that we've developed called Turbo Channels, where you can actually get your channel opened instantly with Bitcoin in it that's instantly spendable, but we had to break the protocol. We had to not use the rules, so you have to use a specific wallet that works.
Yeah, I definitely want to point people towards Pierre's Node Launcher. Definitely the best way to get started. And I mean, the great thing about the path to being a developer is first you have to become a user of the Lightning Network. So throw some sats on your node, go buy some YALS articles, go, just play around with it. And then sooner rather than later, your mind will start coming up with things that, you can build that are empowered by Lightning. And then you've already got the node. You can get going.
Go to lightning.how to see my Lightning resources page, which will have all of these things, all of the different node software and hardware. There's a lot of different options to choose from. You should try them all.